Hi, I'm Chad Tyndall, and I'm a Principal NoSQL Specialist Solution Architect here at AWS. I've been here 4 years. I'm based out of New York City, and I spend most of my time working with financial service institution customers, helping them to migrate their apps to DynamoDB and optimize their apps once they're in production. I'll have my colleague introduce himself, and then we'll dive right into the presentation.
Hi, my name is Sean Shriver, and I'm a DynamoDB Solutions Architect. I have been with AWS for about 9.5 years and focused on DynamoDB for about 6.5 years of that time. I am based in Dallas, and I work with all sizes of companies from small businesses all the way up to enterprises and help them to be successful on DynamoDB.
Okay, today we're going to be talking about the cost optimization pillar of the well-architected lens. DynamoDB is unique in the sense that it not only allows you to scale up to meet any requirements that your applications may have, but it also allows you to very rapidly scale back down, even scaling your IOPS down to 0, so that you can really optimize your costs when you're not using the database very heavily. Let's very quickly look at a few design considerations that we're going to dive more deeply into as we jump into this presentation. The most important design consideration is how you configure your capacity mode for DynamoDB. There's two capacity modes, on-demand capacity and provision capacity, but we always recommend that customers are either running with provision capacity with auto-scaling turned on or in the on-demand capacity mode. This allows you to have your costs scale up and down with your application's utilization of the database.
And if you go with the provision capacity mode, you can use reserve capacity, which is a reservation bought in 1 or 3 year terms. And we'll dig into that in a little bit, but it does lower your total cost per unit in the provision capacity mode.
There's an alternate storage class you can use if you have storage which is kept for long periods of time but infrequently accessed. It's called the infrequent access storage class. And this is something you want to use if your storage costs exceed 50% or more of your throughput cost. So we'll look at some graphs explaining this when we get to that slide.
And then there are a couple of design considerations you can use when you're structuring your data in DynamoDB. These are the front end decisions you make when you figure out what are my keys, what's my data structure. So for instance, you could separate the frequently changing data, such as pricing information, from the metadata, such as links to the images, into separate items under the same partition key. Or you can consider separating the less frequently read attributes into separate rows. And in either way, through the data structure and the design of your schema, you can control your costs and your read capacity required to read and write your data in DynamoDB.
Because your costs in DynamoDB are based on the size of the items that you read and write from your table, you want to minimize the size of those items or rows as much as you can, which means if you have large binary blobs, it might be more cost efficient to keep those binary blobs somewhere else in S3 and just store the metadata about those blobs that you want to display in your API or on your website or have people allowed to search and filter on. Keep those in DynamoDB for very rapid access, and then when they actually need to see the blob or download the blob or whatever it is, then you can go to S3 for that.
And also consider the DynamoDB item structure. As we'll cover here in a little bit, when we look at a DynamoDB item, the attribute name is stored locally at every item. So if you have a 100-byte item, that's going to include the size for your primary key, your attribute names, along with the values. So if you actually shrink down the name of your attributes from, say, something like full name, quote unquote, to just 2 letters, FN, you're going to shrink that item size. And considering you might have millions or even billions of items in your DynamoDB table, that cost savings adds up to shrink down your attribute names.
And the last bullet point on this slide is basically pointing out that if you have large items, one way to shrink their size and therefore reduce your costs is to compress some of the attributes in those items that don't need to be searched or indexed on to make the item smaller.
So we have a feature in DynamoDB called Time to Live, and we'll once again touch on that in a little bit. But TTL is a great feature to control the size of your table and to remove unwanted data at no additional cost to you. And that's something that you may want to consider instead of deleting items, which do incur cost if you do that directly.
If you're taking backups of your DynamoDB table, one of the features of AWS Backup is called a backup lifecycle. This allows you to take backups that roll over to cheaper storage after a certain period of time. So if you are keeping those backups for long periods of time, then moving them to cheaper storage may help you save money in the long run.
DynamoDB also supports a feature that's common in other AWS services where we allow you to apply tags to your DynamoDB table to allocate costs to different cost centers, and then in the cost and billing dashboard, aggregate and group data by those cost allocation tags. So we would consider that you want to use those as you're structuring your data and building your tables in Dynamo.
We'll look at some examples of using Lambda event filtering essentially to reduce the number of Lambda invocations on your DynamoDB and Kinesis stream events triggered by changes in your DynamoDB table.
Consider using DAX for read-heavy workloads. There is a certain trade-off that our customers find where by using DAX, they can provision fewer read capacity units. So DynamoDB Accelerator or in-memory write-through cache service is something that you should consider using to lower your read costs.
When you're running queries in DynamoDB, you want to maximize the use of a highly selective key condition expression. Essentially, this just narrows down the number of items that DynamoDB needs to touch while it's building your result set for the queries that you run. And so the more highly selective your query is, the cheaper your queries are to run. When you build indexes in DynamoDB, you can control which attributes from your base table get copied or projected into the index. So you can actually make your items in the index smaller than they are in the base table. This allows you to really control your costs because perhaps your items in your base table, let's say, are 10 or 20 kilobytes, so reading them will have a certain cost associated with them. But if you project them smaller by stripping out unnecessary attributes, depending on the access pattern, you can reduce your cost significantly by making the rows in the index smaller. And you want to keep an eye on what indexes you have and which ones you're actually using. It's possible that maybe you needed an index for a certain access pattern, and then a few years go by and that access pattern gets taken out of the application, but the index that was built to service it might not get taken out, and it can be sitting there costing you money even though you're not using it.
Yeah, that's certainly something I've seen in many of my customers' tables as we review them, and we find these indexes that they actually don't know who made them. And then one thing to consider is using VPC endpoints. DynamoDB today offers VPC gateway endpoints to connect your VPC to the DynamoDB service, and that's provided at no additional cost to you. So you create the VPC gateway endpoint, attach it to your VPC, and then send your DynamoDB traffic to the DynamoDB service. And that way you don't have to pay for a NAT gateway or for any NAT instance or anything like that. Do be aware, though, that VPC endpoints are only available for DynamoDB, not for the DynamoDB Streams API. It's not accessible. That API is not accessible over VPC endpoints.
Okay, let's jump into some of the details for each of these design considerations and drill down a level deeper. We talked about choosing the right capacity mode. This is far and away the most important decision you have to make in terms of controlling your costs and optimizing your costs in DynamoDB. There's two modes, provision capacity and on-demand capacity. So with provision capacity, you're telling DynamoDB at any moment in time how many reads and writes you want to be able to service from your table. And we have a functionality that's paired up with that, which is called autoscaling. So you can tell DynamoDB as your workload increases, your reads go up or your writes go up, that autoscaling should increase the amount that's provisioned for your table. And with on-demand, you don't need to tell DynamoDB how much capacity you're going to use. DynamoDB just watches your workload and figures it out. Unlike provision capacity, where you pay for what you tell DynamoDB to provision for you, in on-demand mode, you just pay for what you use. So if your workload goes up, your costs go up, and if your workload goes down, your IOPS cost goes down, even including all the way to zero. So if you have periods of time where you're not servicing any requests, then on-demand mode can help you save money because during those times, you'll be paying nothing from an IOPS perspective.
Yeah, and if you're unsure about which capacity mode to start with, go ahead and begin with on-demand, and then monitor the table's consumption, look at the traffic. At any point, you can switch back to the provision mode if you're on-demand, but, be aware you can only switch to the on-demand mode, hop over from provision to on-demand mode once per calendar day.
Yeah, it's not uncommon for new applications to start in on-demand mode, especially if they know they're going to be lower utilized or have periods of less downtime, and kind of watch it for a month or two. Then you can make a decision whether it makes sense to switch over or not. There's also workloads, for example, that have a large bulk access pattern maybe once a day. You get a nightly drop from another system and you need to ingest it. So we've seen workloads where they run in on-demand most of the time during the day, And then when they go to run that large bulk job, they'll switch to provision capacity for some period of time while they do that. Maybe it's just for an hour, and they'll do their large bulk job, and then they'll switch back to on-demand mode when that job is over. Again, like Sean said, you're allowed to do a round trip on-demand to provision capacity and back to on-demand once every 24 hours.
The provision capacity mode is often and highly recommended that it be used with the auto-scaling feature. So we normally talk about provision capacity with auto-scaling enabled. You can enable it on the base table and on the global secondary index. As you configure it, you'll have to make some considerations. For example, what should your target utilization be, which is about where the auto-scaling service wants to have your utilization at when it looks at your consumed and provisioned. You also want to consider how much you want to spend, which is your maximum capacity, the kind of the upper limit of the scaling of the table, as well as the minimum capacity. And those three settings, the minimum, the maximum, and the utilization, are something that you're going to want to adjust over time, because we don't want you to under provision the table in a way where you could have surge requests and get throttled, or over provision the table, say going with something like a 20% utilization, or going with a high minimum capacity relative to your normal workload, and potentially pay for a lot of provision capacity that you're not using. So it is definitely a process that takes work and time, but over time, as you get familiar with your workload, you'll be able to tweak your settings for provision capacity mode to get the most out of your capacity units and to limit any waste that you might see in your unused capacity.
And now the rules of thumb for how to choose from on-demand or provision capacity is that, generally speaking, new workloads go with on-demand. And if you're unsure about the consumption patterns, then on-demand is a great first choice. If you know that your workload is going to be very bursty in a way where auto-scaling can't keep up with the bursts that are coming in, then on-demand is a good choice. And if you're just sort of willing to say, I just don't want to think about it, and so I'm willing to pay a little bit of a higher rate to avoid having to manage my capacity at all, then on-demand can be the right choice. Provision capacity works really well if you have workloads with predictable traffic patterns. So you know what those traffic patterns are going to be, and those patterns have smooth ramps up and down in a sort of a sinusoidal type motion where your customers wake up in the morning and traffic gradually ramps up and it peaks during the day or in the evening. And then at night, when your customers are signing off or going to sleep, traffic goes back down. And if it has this smooth ramps up and down, then provision capacity with auto-scaling generally works very, very well, because the auto-scaling has time to react to the traffic increases that are coming in a smooth motion.
And one thing that we see customers ask us about is, if I have a bulk load that's happening at some point in the future, can I use provision capacity with auto-scaling? And the answer is yes, because you can schedule the scale using the APIs for application autoscaling. DynamoDB autoscaling uses application autoscaling. So if you know at midnight of every day you're going to have a bulk load, you can still use the provision mode by putting a scheduled action onto the autoscaling service, and that way the table's minimum capacity will be adjusted. So it's not I have a spiky workload or I have an ETL and I need to use on demand kind of decision. Oftentimes the provision capacity with autoscaling mode can still be used in those cases. It really just depends how big is that spike and how predictable is that bulk load. Speaking of provision capacity, we offer reservations at 1 or 3 year terms to lower your total cost per unit. It requires an upfront commitment and an upfront cost. It can be difficult to decide how much capacity you need to purchase, but we do have tools available for you, some that are open source, that are going to look at your cost and usage report data and make a recommendation about how much reserve capacity you need to own. Now, if you're familiar with EC2 reserve capacity reservations, that knowledge will apply in large part over to DynamoDB, but be aware of some considerations. Now, the first thing is that these reservations are only available for provision mode and not for the on-demand mode. In addition, reservations only apply in the region where they are purchased. So unlike EC2, where you get to decide availability zone And instance type with DynamoDB, it is simply region, and capacity mode is either write units or read units. Speaking of write units, reserved capacity is not available for global tables, which use an RWC unit. In addition, they're not available for the standard IA table class. So if you have a DynamoDB reserved capacity reservation, you cannot apply that to any tables that are in the standard IA table class. So reserve capacity is a great way to save up to about 74% at the 3-year term with the reservation. And overall, it's going to allow you to have a lower cost per unit. And that's what you need to know about reserve capacity. Now, speaking of standard IA, Chad, do you have some information for us about standard IA?
There are two what we call table classes inside of DynamoDB. There is the standard table class, which is the normal one. That's what you get by default. And then there's the standard IA, or infrequent access table class. The standard IA table class allows for lower storage costs, in fact, 60% lower storage costs than the standard table class. It provides the same performance, so there's no performance trade-off here. This is literally just a cost model and deciding how you want to pay for things. So the same performance, durability, availability, scalability, it's all identical. If you switch between standard and standard IA, you won't notice any performance trade-off, even temporarily. And there's no overhead for doing this, so this is just an administrator's choice. This doesn't affect your developers or how they build their applications or how you model data. You can just point and click with a single change in the DynamoDB console to switch between standard and standard IA table class. It is fairly common for applications to see their storage costs grow over time. Usually when applications start, there's no or very little data inside your DynamoDB table, and then after a few years of running your application, your storage grows and grows as you accumulate more and more data. So if when you're looking at your cost and usage report, your storage cost exceeds 50% of your throughput cost, that's sort of the break-even point here, and that's when you would want to consider switching from standard to standard IA. And that should help lower your total costs over time, because presumably your storage costs will continue to grow and grow and grow if this is the situation that you find yourself in.
All right, Chad, let's have a conversation about storing large items in DynamoDB. One of the questions I ask my customers, even though it may seem pretty basic, is, do you actually need to store this data in DynamoDB? Meaning, does it need to be persisted in 3 locations? Do you need a single-digit millisecond latency for retrieval? And do you need the durability that DynamoDB provides? And if we can't check all those boxes, then perhaps DynamoDB isn't the right place. So Chad, how would you start it out? What are some of the things that you would check to consider? Is DynamoDB the right place? Maybe is there ways that we can fit the data for an item into DynamoDB?
Yeah, well, obviously we always start this conversation with what is the data model and what are the access patterns. Is this data that you're going to use frequently, and do you need it retrieved very quickly when you do need to use it? That's always where we're going to start. If it doesn't need to be used frequently, or it's okay if it takes a little bit longer to retrieve the large attribute values, then potentially you could store those in S3 and just keep the metadata about them in DynamoDB so that you can show data about those attributes in your user interface or allow users to search and filter on them. That's why you want that stuff in DynamoDB. And then when they actually go to download or view the large item, right, then you can pull it from S3. If you do need to keep it inside of DynamoDB, then sometimes it can be advantageous to split your item into multiple items or multiple rows, where you might have the large attributes in a row that isn't written to or read very frequently, and then you have the attributes which are written to or read more frequently in a separate row. That way, when you're reading and writing a very small row. That's the stuff that gets used frequently. And then you only need to access the large row, which has a higher cost. You only need to access that row infrequently, and that'll help you save money. DynamoDB has this concept of grouping items under the same partition key. So it's possible to group them here, as you see on the image on the right-hand side. They're grouped under the same partition key with different sort keys. And that allows me to access both items together if I need to read them both out. Right? I can say, get me all the items that have this same partition key, and I get all of the items back, including the large item. Or I can say, just get me the item with the metadata sort key, and that gets me the small item back when I don't actually need the large blob.
Now let's talk about the shrinking of attribute names. every item in DynamoDB has a full copy of the attribute names. It is like a JSON document when we store it in DynamoDB. And when we bill you, it is billed based on the size of that document. So in this example, what we do is we take something that has full name, birth date, and home address, which are long attribute names, and we shrink those down. And although for a small number of items in the thousands, that byte savings doesn't add up, it will quickly add up if, say, you have a billion items. So in this example, we shrink these attribute names down, which takes our item size from 66 bytes down to 44 bytes, which leads to a substantial savings in cost. And if you're looking to figure out how much would I potentially save in bytes, there are some item size calculators out there that you can search for. One is the ZAC Charles item size calculator, or you can search for some other ones. Even our documentation for DynamoDB explains the relationship between the length of your attributes and the item size in DynamoDB. And adjusting your attribute names to be smaller can have a large knock-on effect. In this example, we see an item that shrank below the 1 WCU boundary, which in DynamoDB is 1024 bytes. That's what's equal to 1 WCU. And so the item size shrinks from 1025 bytes to 995 bytes by going from attribute names like full name down to FN. So instead of requiring 2 WCUs to update an item, we now only need 1 WCU. And as you can see in this example, this leads to a 50% reduction in the write capacity units required on this table. So imagine you can say, hey, I decreased my write costs by 50%. And that can be done in this example by shrinking your attributes so they're just a little bit smaller. So consider the bigger impact that your item structure has on the item size and how that will affect not only your storage and your bytes, but also your capacity units and allow you to more efficiently use the capacity units that you have.
If you have a data model that naturally expires data after a certain amount of time and you want that data to be removed from DynamoDB when it's no longer necessary, the best way to do that is to use our TTL or time to live feature. Essentially what you're allowed to do is you're allowed to set an expiration time on a per item basis to tell DynamoDB when a particular item should be considered as expired. And DynamoDB will automatically remove this item from your table after it's considered expired at no cost to you. So this is a very, very good way to reduce your bill if you have data which you can automatically delete after a certain amount of time.
DynamoDB is supported by the AWS Backup Service through advanced backups, which allow you to schedule and have policies for retaining backups for a certain amount of time. In addition, it allows you to put retention policies, to do cold storage, transitions. It will allow you to choose your own encryption key, in addition to things like copying backups to other AWS accounts or other regions. Now, a cost consideration with the AWS Advanced Backups for DynamoDB is that if you need to use cold storage, you can do that, and it's going to lower your cost per backup. However, be aware that if you use the cold storage backups, you need to retain those for at least 90 days. So, AWS Backups provides a lot more control on where your data is stored in your account or in other accounts or in other AWS regions, and it automates the backups for you, in addition to lowering your cost for those cold storage backups, which you need to keep for longer than 90 days. So be aware of that and how it can help you to lower your cost and also provide you a peace of mind that your data is backed up and reliably stored in encryption in an AWS Backup Vault.
Well, DynamoDB has this ability to put change event records into either DynamoDB stream or into a Kinesis data stream, which allows you to trigger Lambda functions anytime your table changes. It's not uncommon to only want to trigger Lambda functions on certain types of events. Maybe you only want to do a Lambda function when an item gets deleted from your table so that you can archive it over to S3 or something like that. But whatever it is, if you only want to trigger Lambda functions on certain events, you can use this feature of Lambda, which is called event filtering, which allows you to define filter criteria so that your Lambda functions only trigger and run on certain events, but not all of the events. And this can help you lower your bill by just invoking fewer Lambda functions over time. When you start the process of applying this well-architected lens to your workload, these are some questions that you want to ask yourself as you go through that. So again, the first thing that you want to think about is how do you choose your capacity mode for your DynamoDB tables? And frequently this will be based around the traffic pattern that's coming into your workload. Is it relatively predictable with smooth ramps up and down in traffic? Then you might prefer provision capacity with auto-scaling turned on. Is your workload unpredictable and spiky? Then you probably want to use on-demand capacity. And if something changes, then you can change which capacity mode you're using. That's not a problem. There's no cost to change it. You're allowed to change it back and forth once a day. So you can always start with one and then transition to another if you feel like that's more appropriate.
You want to consider how you will store maybe older data or colder data in DynamoDB, and consider using the Standard-IA table class.
Does your workload have a lot of update operations that get applied to the data? If so, you might want to consider splitting those items that have a lot of updates into two parts, the part that changes frequently and the part that doesn't change frequently. And this can allow you to lower your write costs by having the item that changes frequently be as small as possible.
And consider the lifecycle of data in your DynamoDB table. If you have unwanted data that you want to remove, consider using TTL. And DynamoDB will remove that data from your table at no additional cost. Speaking of cost, in order to monitor usage and cost for DynamoDB, enable the cost and usage reports, which provide data on how you are spending money on DynamoDB, which is important for making decisions like, should I be using the Standard-IA table class? The DynamoDB billing data can be visualized in the Cost Explorer, and the cost allocation tags will allow you to group your data and visualize and allocate your cost for a DynamoDB table to a particular application or business unit.
Understanding your backup policy is important for optimizing the costs of those backups. For example, how often do you need to take the backups and how long do you need to retain them for? If you have backups that need to be retained for 90 days or more, it can be cost effective to transition those backups over to cold storage, and this is something that the AWS Backup Service can help you achieve.
Consider using DynamoDB Accelerator or DAX for heavily read-skewed workloads. So if you have a lot of reads on frequently accessed data, consider using DynamoDB Accelerator for that.
Usually when you go and map out all the access patterns for your application, some of those access patterns get used more frequently than others. And you really want to take a look at the most frequently used access patterns and make sure they are using the most highly efficient key condition expression to avoid expensive scan and filter operations when running queries for those access patterns.
And at the end of your optimizations, once you have enough billing data to see what your normal utilization will be in the provision mode, consider purchasing reserved capacity using the tooling that AWS has provided to find the right amount of capacity to own to lower your total cost per unit on DynamoDB tables, remembering that Standard-IA cannot use reserved capacity, nor can global tables, or of course, on-demand usage.
Optimizing your costs is an important part of using any AWS service, DynamoDB included, and it involves a mixture of proper schema design based on your access patterns so that you can service those access patterns most efficiently, as well as using the proper table settings based on your application's requirements. Thanks for listening, and hopefully you picked up a few tricks to save some money along the way.